All right, ladies and gentlemen, we're starting 9.2. So overall, we're still talking about probability, but the idea here is if you have dependent or independent events, how do they affect each other? How can we calculate the probability of those two different events happening? So what we're looking for, we're actually taking an example that we did in 9.1, and we have the same chart. Students taking the quiz randomly guesses the answer to 4 true or false questions. Use a sample space to determine whether guessing question 1 correctly and guessing question 2 correctly are independent events. In this case, we're going to check if they are. So we've got the same table where we have zero. We could answer none of them correct, 1 of them correct, 2 of them correct, 3 of them correct, 4 of them correct. And to answer 0 of them correct, there's 1 possible outcome that gives us that. To do 1 correct, it's 1, 2, 3, 4. I believe this one is, yep, 6. This one was 4 and 1 for a grand total of 11, 15, 16 possible outcomes. So to be able to say that we got the first question correct, we're not actually looking at the left-hand side. We don't care about how many times how many number we got correct. We're actually saying, did we get the first question correct? I see that happen. Oh, there we go. I see it happened here. I see that happened here and here and here. I see it happened here, here, and here. And I see that happened here. So I have a total of 1, 2, 3, 4, 5, 6, 7, 8 times that I got the first one correct. And I had a total of 16 times possible. So with that, I can simplify that just to be, what is that, 1 over 2? Or a 50% chance. Now, I'm not going to take that percent yet. I could, but the furthest I want to take it is into decimal form. So there's almost no need to turn it into decimal if I can do it in fraction. We'll see why here in just a second. Okay, the second one is if I get the second one correct. Now, there could be some overlap here, so we got to look at it. Second question correct is happening here. It's happening here, overlap. It's happening here and here. Second one right. Second one right, second one right, second one right. So we got 1, 2, 3, 4, 5, 6, 7, 8 times that happened. So I have 8 out of the possible 16 times. So again, that's going to be 1/2. Now the last one is the idea of getting correct question 1 and question 2. And when we're talking about that, all it means is we're going to multiply the probability of getting the first answer right times the probability of getting the second one right, which means I actually need to take that out and put here, multiply. So I have 1/2, because that was the probability of getting my first question right, times 1/2, which in this case was the probability of getting the second question right, which is 1/4. Now, again, all we're saying is the probability of A times the probability of B is the same thing as saying the probability of A and B. So because it's 1/4 and because finding out A and B, we just count those up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 16 end up being the same. I had to pause. Okay, sorry. Because 1/2 times 1/2 is 1/4, and 1/4 does not equal the 3/4. So if I counted up all the times I wanted to be correct, all the highlighted ones and even the double highlighted ones, but I only count them once, then according to this table, I should have a 3/4 probability if they're dependent. I find that I had a 1/4, so these are independent events.